In this video, we're going to consider the homologous series of the carboxylic acids. So we're going to look at the functional group for the carboxylic acids. We're going to look at the general formula and the first four members of the carboxylic acid series. And then finally, we're going to consider some of the reactions of the carboxylic acids. Okay, so the functional group for the carboxylic acid series, they contain a COOH group. That looks like this, so C with a double bond to an oxygen and then another bond from that C to another oxygen, which is joined to a hydrogen. So this part of this molecule here is the carboxylic acid functional group. The rest of the molecule can be carbons or alkanes, alkenes, etc. The general formula for the carboxylic acids is CnH2nO2. So in this example here, we have two carbons, so N is 2. We have 4 hydrogens, so 2 times 2 is 4, and we have those 2 oxygens. Some examples here. So the smallest carboxylic acid is methanoic acid with just 1 carbon, 2 hydrogens and 2 oxygens. The structural formula HCOOH, and you can see here the displayed formula showing all of the bonds. Ethanoic acid, C2H4O2, CH3COOH, and the structure here. Ethanoic acid we met in the previous lesson when we were studying the alcohols. Ethanoic acid is produced when ethanol undergoes oxidation either using atmospheric oxygen, so the microbial oxidation, or using an oxidizing agent like potassium dichromate. Ethanoic acid as a solution is known as vinegar. Its old name is acetic acid, which you may have heard of. So ethanoic acid is quite a common carboxylic acid. 3 carbons would give propanoic acid, and you see the structure there. And as you'd expect, 4 carbons in the acid would be butanoic acid, and there's the displayed formula for butanoic acid. Okay, we're now going to consider the reactions of the carboxylic acids, and to start with we'll watch a video to illustrate those reactions. Into these test tubes I'm going to place some ethanoic acid. So into the first tube I'm going to add some universal indicator solution. And we can see that the universal indicator has gone an orange colour, which tells us that the ethanoic acid is only weakly acidic. Into the second tube, I'm going to place a strip of magnesium ribbon. Magnesium is a reactive metal. We can see that the magnesium is effervescing with the ethanoic acid, so it's producing a gas. And what we're going to do is just put a boiling tube on top of that test tube to collect the gas, and we can then test to see if that gas is hydrogen. You notice that the reaction is relatively slow compared to stronger acids, but it is reacting. Okay, so I'm just going to test the gas that's been produced in this reaction here. So it should be hydrogen. Put a lit splint to the mouth of that tube and it gave a squeaky pop. Into the third tube we're going to place some sodium carbonate solution. And therefore, because it contains a carbonate, if it reacts with the acid, we should see some effervescence again as it produces carbon dioxide. So just watch carefully. And so, as you'd expect, an acid plus a carbonate produces a salt, water, and carbon dioxide. The carbon dioxide we could test with lime water, could bubble it through lime water, and lime water would go cloudy. The salt in this case would be sodium ethanoate, so ethanoic acid would give ethanoate salts. Okay, so summary of this of these reactions. So first of all, carboxylic acids are weak acids, which means they react a little bit more slowly than strong acids like hydrochloric acid. Their pH is a little bit higher. Generally, carboxylic acids have a pH of about 4 as opposed to pH 1 for hydrochloric acid, sulfuric acid, etc. But they are acids, so they do normal acid reactions, such as react with reactive metals or relatively reactive metals like magnesium. And we have an acid plus magnesium produces salt plus hydrogen. The name of the salt from ethanoic acid is ethanoate. So when you name the salts of carboxylic acids, instead of the name ending in oic acid, the name ends with oate. And we've got the equation there, the chemical equation for that reaction. The other reaction we saw was with sodium carbonate. This time I'm using as an example butanoic acid plus sodium carbonate, making the salt sodium butanoate plus water plus carbon dioxide. The carboxylic acid salts, when they make the salts, the hydrogen at the end of the carboxylic acid, the end attached to the oxygen, is the hydrogen that makes the H+ and comes off the acid and produces a 1- charged ion. All the other hydrogens attached to the carboxylic acid remain attached to the carbons. It's only the hydrogen attached to the oxygen which is removed when the carboxylic acids behave as acids. So in this lesson, in this study of the carboxylic acids, we've looked at the functional group of the carboxylic acids, so they contain COOH groups. The general formula of the carboxylic acids, CnH2nO2. First four members of the series, methanoic acid, ethanoic acid, propanoic acid, butanoic acid. And the carboxylic acids react as acids. They're weak acids, but they do react with reactive metals and with metal carbonates.